The purpose of chemistry is to understand properties of matter and its changes. And in order to do that, because it's a complicated world, we need some way of organizing and categorizing matter. And we've looked at that already. So now we're going to focus at one very important organizing principle, and that's looking at the properties of matter. So it is by cataloging the different properties that different samples of matter have that we understand how they are different from each other, and that we can identify them as one kind of chemical or another. So that's all based on their properties. So an understanding of properties and how they change is really central to the beginnings of understanding chemistry. So we categorize different types of properties into different categories. The first category that we're going to look at are intensive properties. So when you hear the word intensive, you can think that means internal. It's something inherent, part of the makeup of the stuff that you're talking about. So intensive properties are defined this way. They don't depend on the amount of stuff present. So if you have 10 times more stuff or 100 times more stuff, the value of whatever property you're trying to measure, or the qualitative measure of whatever you're trying to measure, does not change. And so here's some examples of some of those things: color, hardness, pressure. Down at the bottom you see a very important intensive property that we're going to be using a lot, particularly early on here in the class, and that's density. So density measures the amount of stuff that gets packed into a given space. Materials of high density, if you have a small volume, they will have a large mass, whereas materials with low density, the same volume, will have much less mass. And so it's defined by this equation right here: d for density is equal to mass divided by volume V. So if you know the mass and you know the volume, you can divide those two, and then you'll get density. So density doesn't matter how much stuff you have present. The density of water at room temperature and pressure is the same whether you have a swimming pool full of it or a test tube full of it. The contrasting type of property then are extensive properties. So these are properties that do depend on the amount of stuff present. And so here's some examples of some things that are extensive. So those two properties, mass and volume, that we looked at in defining what density was through that equation, well, those are both extensive properties. So you have 10 times more mass, 10 times more stuff, you have 10 times more mass, right? Maybe it takes up a larger volume. So those are all extensive. More stuff you have, the more these properties might change. And I have a note here that often if you take the ratio of two extensive properties, you will get an intensive property. So for example, mass and volume are both extensive properties, but when we divide them, we get an intensive property, density. Here are two more categories of types of properties. So we can categorize properties as being physical properties. We've already seen some examples of some physical properties when we looked at mixtures and separations, and just now density is an example of a physical property. So a physical property, what is that? Well, it's a property that you can observe or measure without changing the substance into another kind of substance. So there's no changes in the types of chemicals present involved in that. So examples are things like boiling point. So all you're doing is heating the substance up, converting, say, liquid water into water vapor. Still water, it's just a change of state, we say, going from a liquid to a gas. Density is a physical property. Temperature, color, luster, which is the shininess of a material, hardness, viscosity, which is resistance to flow, and solubility, which is how well it dissolves into a particular solvent at a particular temperature. Solubility is a little bit funny here. It is a physical property. Your book considers it a physical property. But sometimes, like if you're dissolving a salt, sodium chloride, there's some chemicals, like sodium chloride, that when you dissolve them, they dissociate. They break up into smaller numbers of particles. So it's hard to say, is that a chemical change? Have you changed the chemical identity? If you boil off the water that salt might be dissolved in, then you're left with the salt just that you had initially. So is that really a chemical change when you've broken it up? So there's a little bit of room for debate in some of these categories, and that's okay. That's pretty typical of things that we invent in our minds, we humans. So the next category of properties, contrasting, are chemical properties. And so these are properties that can only be observed by reacting it with another substance. So here you're going to get a change. There's going to be a conversion of one substance to another when you test for this property. So these might be flammability, how well does it burn in oxygen, or acidity, how much does it behave like an acid, or certain types of reactivity, or maybe the reduction potential, which is related to oxidation, reduction, corrosion, those types of processes. So if it's a corrosive material or flammable material or acidic, basic, alkaline, these are all related to chemical properties, dealing with how chemicals react with other substances. And in the course of that reaction, they are changed. So you can only test for chemical properties by inducing a change. So if you have evidence of a change when you're measuring some property, well, it's a chemical property. So speaking of changes, we can also describe changes as being either physical or chemical. So physical change doesn't change the chemical identity of the substance in the sample. So some examples, tearing a piece of paper in half, boiling water, melting ice, filtering a solution. These kinds of things are all physical changes. Chemical changes, though, do involve changing the identity of the substance. They always involve some sort of chemical reaction. So I have some examples here. Tearing a piece of paper is a physical change, but burning that same piece of paper, well, that's a chemical change. There's evidence for that because you get the black charred material, there's smoke produced, so there's been a chemical change. I have some other examples. Testing pool water for chlorine. So there are indicators there that react in a particular way, and those substances are changed in the course of that reaction. Mixing an acid with a base, that produces a reaction. You guys have probably done the baking soda vinegar thing. So that produces a reaction. There's fizzing. Sometimes there's heat released. So because of these changes, we know that there's been a chemical change, and that's how we categorize them.